In this video, we're going to look at the formula for calculating the volume of cubes and cuboids, and then how to calculate the volume of any prisms, whilst also making sure we're using the correct units of measurement for the calculations. Before watching this video, make sure you've looked at the measurement and conversion video, and also the video on perimeter and area. Many of the processes used in those ones are used once again in this one. Here, we're looking at calculating the volume of a cube or a cuboid. The volume is the space taken up by a three-dimensional shape, or you could consider it the space inside the shape. In order to calculate the volume, you multiply the length times the width times the height. To be honest with you, the names for these measurements are a matter of perspective, as they could change depending on how you're looking at it and which way round the cuboid is. The main element is that you are calculating using all three dimensions to calculate the space inside the shape. Remember, a cuboid is made up of rectangles and possibly squares, whereas cubes are constructed solely of squares, meaning all the edges have the same length. It's important to remember this if they ask you to calculate for a cube and then only give you one of those dimensions. So if we were to say that the length of this cuboid is 10 centimeters, the width is 5 centimeters, and the height is 6 centimeters, we could calculate the volume by doing 10 times 5 times 6, which will equal the volume of 300. As we're dealing with centimeters and calculating volume, we'll state that the volume is 300 centimeters cubed. They may ask you to calculate this in liters, so it's a good idea to remember that to convert from centimeters cubed to milliliters is a straight conversion. It's 1 centimeter cubed equals 1 milliliter. So 300 centimeters cubed equals 300 milliliters. And so that's going to be the answer if they're asking for capacity measurements rather than linear ones. On this page, we're going to find the volume of several prisms. Now, let's clarify that a prism is a shape with a front face of any number of sides and parallel straight edges running off to construct rectangles on its sides. It's usually called by the front face's name, as in this shape, which is a triangular face prism. A cuboid could be considered a square-faced or a rectangular-faced prism, but as we use it so often, we give it its own name of a cuboid. The front face shape is reflected in the shape at the back. In order to calculate the volume of any prism, we must first find the area of that front face, as that's going to be the length and height of it. Then multiply it by the depth of the prism. In this case, it's base times height divided by 2, as it's a triangle. 8 times 5 divided by 2 would give us 20 centimeters squared, times by 10 gives us the volume of 200 centimeters cubed. Next, we've got a trapezium face prism. To calculate the front face of this prism, it's the top parallel side of A plus the bottom B, which divided by 2 and then multiplied by the height. In this case, it would be 6 plus 8 divided by 2 and then multiplied by 5, which would give us 35 centimeters squared. Times by 10, which is the depth, would give us 350 centimeters cubed as the volume for this prism. Now we have a pentagonal faced prism, for which we need to calculate the volume. The question often comes up, and some students are worried about calculating the volume of a prism whose face they don't know how to calculate. However, if you understand the formula of front face times depth, you can see that they've already supplied the front face area, and all you have to do is multiply that by the depth. So we can do 64 centimeters squared times 8, which will give you 512 centimeters cubed. So we can say that the volume for this prism is 512 centimeters cubed. Here, we're going to find the volume of a compound prism. This is a shape that has a front area which is a combination of 2 or more recognizable polygons. Here, we could cut the front face into 2 rectangles to find the front area. On the left, there would be 3 times 20, which would equal 60 centimeters squared. And to calculate the smaller rectangle, we need to calculate this upper edge, which is 8 take away 3, and it gives us 5 centimetres. We can multiply by the 2, which we can bring forward from the back face, to be 5 times 2 to give us 10 centimetres squared. Now we can add the areas of these two rectangles together to give us 70 centimetres squared. We can then times that by the depth of 15 centimetres to get 1050 centimetres cubed. Here we've got an exam style question. We've been told that both of these shapes have the same volume, and we're asked to calculate the value of the variable x, which is at the bottom of the triangular faced prism. First, let's calculate the volume of the cuboid, and we can label these with width, length and height, and then calculate the volume to be 7 times 22 times 8, which equals 1232 centimetres cubed. Now if we know that this is the same volume of the triangular face prism, we can write out the formula for the volume with the known values substituted in for the variables. So we're going to have 16 times x divided by 2 and then times by 7. We know this equals 1232. We can now undo this equation to solve for x by changing the subject to this formula to x. First, we're going to divide both sides by 7. So we get 16x divided by 2 equals 176. Then times both sides by 2 to get 16x equals 352. Then divide by 16 to get x equals 22. As this is a single length and therefore one-dimensional, we can state that x equals 22 centimetres. In this video, we looked at the formula for calculating the volume of cubes and cuboids, which was the length times width times height. We looked at calculating the volume of prisms, which was the area of the front face times by the depth, and in all cases of volume, it's important to remember that the unit of measurement is understood to be three-dimensional, and therefore uses a power of 3. In the next video, we'll be looking further into three-dimensional shapes, the names of them, and creating plans, elevations, and nets. I'll see you then.